Welcome to this solution video. If you like it, please give it a thumbs up and share with your friends and subscribe to Math United. Let's start with question number 1. Rajesh applies once every year for a ticket to a musical festival. The probability that he is successful in any particular year is 0.3. So the probability of winning the ticket is 0.3. Yeah, and that means P, which is probability of success, is 0.3. Q, which is the probability of failure, will be 1 minus 0.3, which is 0.7. Okay, find the probability that Rajesh is successful for the first time on his 7th attempt. That means he fails for 6 times. That means q to the power 6 and then passes, then he gets success. What is q? Q is 0.7, so we'll write 0.7 to the power 6 and multiply it by 0.3 success. That will be the probability that he gets success for the first time on 7th attempt. If I use my calculator, I get 0.03529. 0.0352947, which we can round off to 3 significant figures, 0.353. Okay. B part, find the probability that Rajesh is successful for the first time before his 6th attempt. So that means before 6th attempt, right? 6th attempt. That means he gets success from 1st to 5th, anywhere between 1st to 5th, right? Which means that he does not fail in all 5 attempts, first 5 attempts, and does not fail, we'll subtract it from 1. So it means 1 minus 0.7 to the power 5 subtracted from 1, and we get that equal to 0.832. This is the probability that he succeeds within 5 attempts. Quite a high probability. Okay. Find the probability that Rajesh is successful for the second time on his 10th attempt. Second time, not first time, okay? So the 10th attempt is success. That means probability is 0.3 on the 10th attempt. But from 1st to 9th, it means because this is the second time he is successful, there will be only one success. One success and 8 failures, right? In first 1 to 9th attempt, there will be 1 success and 8 failures, and that will multiply with 10th, which is 0.3 success, right? But which one of those is a success, we don't know. So we'll multiply this further by 9C1. Out of 9, there will be 1 attempt where he will get success, but we are not sure, so we'll write 9C1. This is the whole thing we'll put on in our calculator and we'll get our answer. Let me try it myself. By the time I do this, I will request you to like this video, share with your friends, and subscribe to Math United. Okay, what I'm getting is 0.046694. So please, this is a video recorded before the marking scheme is out. So if you see a little difference between answers, please don't mind, and just look at the process by which it is being done, which I am sure is correct. So I will round it off to 0.0467. Question number 2. Seva has a coin which is biased. Okay, it is not a normal coin. It is biased so that when it is thrown, the probability of obtaining a head is 1/3, not 13. So probability of head is 1/3. That means probability of tail will be 1 minus 1 over 3, which is 2 over 3. He also has a bag containing 4 red and 5 blue marbles. 4 are red and 5 are blue marbles. Seva throws a coin. If he obtains a head, he selects one marble from the bag. Okay. So what is the probability of red in this? 4 out of total 9. Probability of blue is 5 out of 9. Okay. But if he obtains a tail, he selects 2 marbles from the bag at random without replacement. That means that marble stays out of the bag. A. Find the probability that Seva selects at least one red marble. At least one. So since when he is getting a head, he is selecting only one marble, and that marble has to be red marble, then only it will become at least one red marble, right? So head and red. Head and red. Okay, this is what we want. So probability of head is 1/3. Probability of getting red is 4/9. This is the case when head is obtained. If tail is obtained, we want at least one of the marbles to be red. So we will have, in that case, we will have either red blue or blue red or red red. These are the 3 cases when we are having at least one red. Here only one case, here 3 cases. In this case, getting the probability of tail, probability of a tail is 2/3 multiplied by, now we have red blue. Red blue will be, first one is red, 4/9. Second one is blue, so blue is 5/9, but since it is without replacement, it will be 5 out of 8 now, because blues are still 5, but the balls in the bag are 8. Blue red, first blue is 5/9, but red will be 4/8. Then we have red, so red is 4/9 first, and then we'll have 3/8, because one red has also gone out. Both are reds, so first one was red, that's why it also reduces. In previous cases, it did not reduce. Just add this and this. Carefully put this in a calculator, and you should get your answer. What I'm getting here is 0.629629 and so on. So we will round it off to 0.630. This is the probability. B part. Find the probability that Seva obtains a head given that he selects no red marbles. So let's say that head is event A, and no red marbles is event B. So we know by formula that A given B, which is asked, A given B is probability of A intersection B when both are happening over probability of just B. Okay, so let's focus on probability of B, which is that no red marble is selected. So again, there will be 2 cases just like previous case. Either head will be selected and then there will be a blue marble, right, because we don't want any red, or tail, but then we have both blue marbles, not even one red. So this will ensure that there is no red marble. So head, what is probability of head? Head is 1/3. Probability of blue is 5/9. Okay. Now the probability of tail is 2/3. Probability of first blue will be 5/9. Probability of second blue will be 4/8. Okay, so I can do it straight away. It will 5/27 plus 40 over 7 times 8, 216. Actually, both of them are, again, if I divide it by 8, it is 5 and it's all 27. Both are 5 out of 27, which is, oh, that makes our job easy. 10 out of 27. And now we have to look at the case when A is there, the head is selected, and B is also there, that there is no red in that case. So this case, which is 5 or 27, becomes our P A intersection B. So it is 5 out of 27 divided by 10 out of 27. Clearly it is half, 1 over 2 or 0.5 is the probability. Question 3. The weights of oranges can be modeled by a normal distribution with mean 131. So if we draw a normal distribution like this, the mean of this is always at the middle and it is 131 grams. And standard deviation 54 grams. Okay. Oranges are classified as small, medium and large. A large orange weighs at least 184. So let's say this is 184. So this area above 184, including 184, is large. Okay. And 20% of the oranges are classified as small. So 20% will be less than, because this is our middle line mean, which is below this is 50%. So 20% will be here. So probability here is 0.2 probability. Okay. So this is small area. Okay. Find the percentage of oranges that are classified as large. Percentage means probability. They are asking probability. We'll find probability and convert it to percentage. That will be there. So this is the area, percentage area we have to find. But when we use our table like this, we do not get more than the specific x value or probability of specific weight in this case. So we will do what? We will find the smaller area, which is given by the table, and then we'll subtract it from 1 and we'll get the area above that. All right. Many of, not many, but couple of you people have asked why I use table, why not calculator? There are two reasons for that. First, we can see in front of our eyes what is the, where is the Z value is standing along with the probability. Also, that in calculators, every calculator has different approach to find the answers straightforwardly. So I would like to keep it simple with one method only. So we need Z value, Z score for this before we proceed. So Z value is, let me write Z when X is less than or equal to less than 184. Okay. The formula for that is the mean minus, not mean, X minus mean divided by standard value, standard deviation. So X is 184 minus 131 over 54. This is 53 over 54. 0.998141. So we will use 9. Okay, 4 is quite close to this, so we can use 98 between 1 and 2. Okay, we'll see what is the difference. So 0.981, we'll see that in our table. 0.98 is here, 0.8365, and then we have 1, which is 3. So 0.8365 plus 3 will be added to the last digit. It will become 0.8368. Since we said we'll have between 1 and 2, so we'll say 9, let's say 9 also. So 0.8369. So probability, Z score was this, probability that X is less than 184 is 0.8368. But we want probability of X being greater than or equal to 184. We'll write 1 minus 0.8369. We decide 9, right? 9, which is 0.1631. It didn't make much difference because we have to write three significant figures, 0.163 or 16.3%. That's what they say. What? Find the percentage, and percentage is 16.3. B part, the greatest possible weight of small orange. That's what we have to find. Small orange, where the probability is 0.2. So we will see probability that X is less than, let's say, some value P, not P, P is being used already. So let me write greatest value, G lesser G. X is less than a value G is 0.2. Okay, but we have to use the Z score, Z value, right? So from 0.2, which is less, right? Obviously this will give us a negative Z score, isn't it? Negative Z score, and there is no negative Z score here. So what will we do? We'll reflect it on the positive side. Okay, so we'll do what? We'll say that there is some place here, let me redraw this, some place here which is 0.2 above a certain place, and we'll get a Z score for that, and whatever is the Z score will be the Z score here in negative, because normal distribution is uniform. But we said this table is for less, not for more. That means we have to look for 0.8, which is below this Z score. Okay, so let's see for 0.8 what is the Z score. The probability is 0.8, 0.7995. This is the closest one, which is 0.8 here, 8 and 4. Now we need to add 5 to the last one so that it becomes 0.8, and for adding 5 it will be 2. So 0.842 is the Z score for this particular part. But we wanted a negative Z score for this one, and that's what we'll do here. We'll use the same formula we used earlier, which is this Z score. So Z score, X is less than G is, we don't know G, which is the X value, minus 131, which is the mean value, divided by 54, and Z score we got as minus 0. How much? 842. 842. And now we will solve it by cross multiplication. G equal to, let's bring 131 also to the other side. 131 will not multiply with 54, only this will multiply. So this will be minus 0.842 times 54. I hope you understand this. This 131 came, but nothing happened to it because 54 first multiplies with this, and then 131 is added because you're subtracting here. And what I'm getting here is 85.5 grams. That makes very much sense. Yes, it is 85 grams here. That is the greatest weight of a small orange. Question 4. The back-to-back stem and leaf diagram shows the annual salaries of 19 employees at each of the two companies, Petrol and Raven. Find the median and IQR of the salaries of the Petrol employees. So the key here is that this means 30,000 and these are hundreds. So if say 30 and 3, it becomes 30,300. That's the key they gave. Okay, so we have to find median first. For median, they should be in ascending order. They are, right? How many are they? 3 here, and then how many? 1, 2, 3, 6 here, 4 here, 3, 2, 0 and 1. So total they are 9 plus 4, 13, 16, 18, 19. Total they are 19 odd numbers. So median will be 19 plus 1 divided by 2, which is 10th position. The 10th data in our list will be the median. Let's count. We'll start from here. 30,000, 0. So this is 2, this is 3, 4, 5, 6, 7, 8, 9, 10. So 32,000 is the median. That's the median. Now for IQR we need lower quartile first, which we'll call Q1. Q1 is the median of the lower half, excluding the median. We'll exclude 32,000. That means this is not part of counting Q1. So if this is the 10th, that means before that we have 9. We'll find the median of those 9. Okay, so that will be 9 plus 1 divided by 2. Fifth position will be the Q1, and it will be 1, 2, 3, 4, 5. 31,200 is Q1. Similarly, Q3 will be the median of upper half. So again the fifth one. So 1, 2, 3, 4, 5, which is 33,500. This is our Q1, Q3. So now we have to find interquartile range, which will be 33,500 minus 31,200. That comes out to be 2,300. That is the IQR. Find the median and IQR of the salaries of petrol. We found both. Okay. Now, second part, the median salary of Raven employees is this. Lower quartile is given, upper quartile is given. Represent the data shown back-to-back system and leave diagram by pair of box and whisker plots in a single diagram. So what I've done, I've already drawn the box and whisker for Raven, because they gave these data, these three data I plotted here. Now I will plot the ones we got. So smallest value here is 30,000, right? Highest is 36,800 for petrol. Okay, so 30,000 and 36,800. So 30,000 is here. So I'll put a dot just above that, which is a little lower than this, and 36,800. So this is 37,000. So we'll be doing little less than that. Okay, this is the highest. Now Q1 and Q3 were 31.2 and 33.5. 31 is here, 2 is little right of that, so here 31,200 and 35, 34,500, 33,500. 33 here, 33,500 is here. So okay, that's the upper quartile. What about the median? Median was 32. 32 is here. 32. Okay, and now we have to draw some vertical lines on these sides. And horizontal line. This may not be that perfect, but with the scale it becomes perfect. So this is for petrol. Now we can clearly see the difference there. Comment on whether the mean or the median would be a better representation of the data for the employees at petrol. We clearly see that the median is much lower, which is the lower quartile of Raven, and there is a clear-cut difference between the middle parts of the two companies. So I think that median is a better way, because if we calculate mean, mean will be lower in this side, this one also, but that will not give you the full picture. So median will be a better selection in this case. In such questions, there is nothing right or wrong. It is how you convince about your point. That's it. Question 5. Jasmine has one $5 coin, two $2 coins, and two $1 coins. She selects two of them at random. The random variable x is the total value in dollars, okay, of these. Show that the probability that the value of x is 7 is 0.2. Okay, so probability, rather, x is equal to 7 when we get 2 5 and 5 2, right? So what is the probability of 2? If we remove the coins, it is 2 out of 5. Yes, total 5 coins are there. 1 plus 2 plus 2, 5, and 2 of them are $2 coins, so 2/5. Now since one coin is already out, yeah, so 4 coins are left, but how many of them are 5? Just one. So this is the one, and 5 2 means it will be either this or this. How we will get x equal to 7? 2 plus 5 and 5 plus 2. So what is the probability of 5? It is 1 out of 5, and probability of 2 will be now 2 out of 4, because 1 5 is out of the collection. So what is that? 2 over 20 plus 2 over 20. It becomes 4 out of 20, which is 0.2 shown. Okay, draw up a probability distribution table for this. So let's do it. Okay, so for that we'll need a table. So first we'll have x, and rather x is really smaller in this case, and then x is equal to x. What is the probability of that? So what is x? What are the possible scores? So if we get both ones, we get 2, right? The score will be, the total value of those dollars will be 2. Then we can have 1 2 or 2 1. So next is 3. Then we can get 2 2, which is, their sum is 4. Then we can get 2 5 or 5 2, which we just did. The sum will be 7. Then there can be 5 1 or 1 5. 6. So these are 1 2 3 4 5 possibilities of sums. So x value is 2 or 3 or 4 or 6 or 7. Okay, we already got the value of 7 as 0.2. So let's find for others, because if 1 1 is, which is giving us 2, the probability will be 2/5. There are 2 coins of $1 each, right? 2 coins. So 2/5 will be the probability of the first one, 2/5, but the probability of the second one will be 1/4, isn't it? 4 coins left, only one of them is 1, because the first one was also 1. So it will be 2 out of 20, 0.1. Similarly, 2 2 will also have 0.1. 2 plus 2 is 4, so it will have a probability of 0.1, because same, there are 2 of them, so it will be 2/5 multiplied by 1/4, so it will be again 0.1. Now this is already done, this is done, and this is done. So we'll talk about 2 1. The probability of 2 is 2/5, and probability of 1 will be 2/4 because 2 has gone, not 1. So 2 will, the number of ones will be 2 still, and but the total number of coins have reduced, and then we'll multiply it by 2 because there are second case 1 2 also. So it is coming out to be 8/20. 8/20 is 0.4, and in this the probability of 5 is 1/5. Probability of 4, for probability of 1 is 2/4, and since there are two cases, we'll multiply it by 2. So it becomes 4/20, again 0.2. Is there some 1, 0.5, 0.6, 0.8, 0? Oh, yes, 1. Total is 1. So this is our probability distribution table for each kind of outcome. Next, find the variance. Okay, for this, the formula for the variance will be variance of x will be sigma x square probability of x minus sigma mean, basically expected value, x px square. This will be the formula, and this is, for that we need to do this one first, where, or rather let's do this one where we have to multiply the x and its probability. So let's do it here. So x is 2, its probability is 0.1. 2 multiplied by 0.1, 0.2, plus 3 times 0.4 will be 1.2. 4 times 0.1 is 0.4. 6 times 0.2 will be 1.2 again, and 7 times 0.2 will be 1.4. This is the expected value which we will square and subtract from. We'll square the x first and then multiply with probability in this case. So square of 2 is 4. 4 multiplied by 0.1, 0.4. 9 is the square of 3. 9 times 0.4 will be 3.6. 16 times 0.1 will be 1.6. 36 times 0.2 will be 7.2, and 49 times 2 will be 9.8. Let's put this in our calculators and we'll get the variance. So this will be 4, 5.6, 5.8, 12.8, 13.6, 22.6, minus 1.4, 1.8, 3, 4.4. This is what we'll get, which is 3.24. This is the variance of this data. Question 6. The residents of Marging were asked to classify their local bus service. 25% said good, 60% said satisfactory, 15% said poor. A random sample of 110 residents of Marging is chosen. Use a suitable approximation. So we do normal approximation only to find the probability that fewer than 22 residents classified their bus service as good. So the success is that they said it is good, and the probability for that is 0.25. That means the failure is 1 minus 0.25, which is 0.75. For normal approximation, we should first test that NP should be greater than 5. NQ should also be greater than 5. So NP, N is 110, total selection, and probability of success is 0.25, which will be 27.5. More than 5, good. So obviously it is 0.75, so NQ will also be more than 5 for sure. So there is no need to do it. If 0.25 is more, 0.75 will also be more. So tested. So we need a mean now, and mean is nothing but NP, which we just got as 27.5. So if we visualize normal approximation, it will be something like this. The mean is 27.5, and we need a standard deviation also, which will be square root of NPQ, which is 0.25 times 110 times 0.75 square rooted, and which I'm getting as 4.54, 3 significant figures. Now our question is that we have to find probability that it is fewer than 22. So 22, if 22 is here, we need fewer than 22, and again the problem is that we'll get a negative z-score in this case, so we will reflect it here, and then we'll get an answer which is lower than that z-score, which is positive for this negative z-score. Let's find negative z-score first. For x being less than 22, so it will be the x minus mean, which is not x actually, it is approximation. So since they said fewer than 22, that means we have to exclude 22. So we'll go 0.5 lesser, it will become 21.5 minus the mean is 27.5 divided by the standard deviation, which is 4.54. So the z-score we get is 1.321. So 1.321 is z-score, and my table is ready again. We'll see 1.3 is here, and that was negative, by the way. That was negative, but we'll take it as positive because we are reflecting it. So 1.32 is 9068 and 1, which is 2. So 0.9068 will be the probability that z is less than 1.321 is 0.9068. So this area under this positive, this area is 0.9068, but we wanted more because it is reflected. Yeah, for finding this area, we have to find this area, which is more. So probability that z is more than equal to 1.321, which is probability that z is less than equal to minus 1.321, it is the same thing, is 1 minus 0.9068. So we have to subtract from 1 so that we get the correct one. It is 0.0932. This is the probability that fewer than 22 residents will say it is good. Very, very low probability. Alright, for a random sample of 10, now they're not 110, they're just 10 of them of margin, find the probability that fewer than 8 classified their bus service as good or satisfactory. So how many said good? Good said 0.25. Yes, good is 0.25 and satisfactory is 0.6. This 85%, that will become our success. So the probability of success P in this case is 0.25 plus 0.6, which is 0.85. So the probability of failure will be 0.15 after subtracting 0.85 from 1. Okay, since there are just 10 of them and we want fewer than 8, so it will be very difficult for list fewer than 8, because 0 is fewer than 8. 1, 2, 3 up to 7, they are fewer than 8, right? I would rather do what? I will write 8, 9 and 10, these only. I'll find their probability and subtract from 1, we'll get for the remaining these so many. That's what I'm going to do. So probability that x, again the variable is x is less than 8 is same as 1 minus probability x is equal to 8 or x is equal to 9 or x is equal to 10. So let's convert this to binomial probability because the four conditions are met here. The probability is same. There are fixed number of selections. There is success and failure, and every time the probability remains same. They are independent, so we can use it. So probability x is equal to 8 will be, out of 10 we want 8 success. The probability of those success is 0.85 and remaining is 2 of them are failure. Similarly here, and all of them are success, so there is no need to write any C in this case. Okay, let's use our calculator. By the time I'm using my calculator, please like this video if you do, and share with your friends and subscribe to Math United. That will motivate me to make many more videos like this. Okay, so it is coming out to be 0.2759, then 3474 and 0.1968. And overall answer comes out to be 0.1799, approximately 0.18. Okay, next part. 3 residents of Marging are selected at random. Find the probability that one resident classified the bus as good, one as satisfactory. So probability of good is 0.25. The other person satisfactory is 0.6, and the last people who said it's poor is 0.15. However, we don't know who said what. So it's possible that the first person said satisfactory, the second person said poor, third person said good. So they can change their place. So we will multiply this by 3 factorial. They can change their place. We don't know who is who. So just do this and you may get your answer. I'm getting 0.135. Question number 7. How many different arrangements are there for 10 letters of this? Nothing can be easier than this. So 10, there are 10 of them. So 10 factorial ways they can be rearranged. However, there are some repetitions. We'll divide by those repetitions. So R is twice, R and R. So we have to divide by 2 factorial. Then we have 1E, 2E, 3E and 4E. Then there is no repetition of G, there is no repetition of N, and A and T are also not repeated. So the answer will be, it comes out to be 75,600. Okay, how many different arrangements are there of 10 letters of this, again, in which 4 E's are together? So let's put them in one box. E, E, they're together. Okay, and the 2 R's have exactly 3 letters in between them. So R cannot be at the 2 ends of this because there are 4 of them, right? So R cannot be here or here. So let's say R is here. Then we have 1, 2, 3. So how many they become? 1, 4, 5, 6, 7, 8, 9, 10, 11. So we cannot have this situation. So we will have to get rid of the first one. Now it's possible that there are 4, 5th, 6th, 7th, 8th, 9th and 10th. There are 10. This is one possibility. Second possibility could be that they don't change their place. These E's remain there, but R comes here. Then there are 3 places in between. And then we have R. So, and there will be one space after that. So 4, 5, 6, 7, 8, 9 and 10. These are the 2 possibilities if E's are on the left side, leftmost side. Secondly, we can have a situation when there is a total reflection of this. These E's are at the end. Obviously, they cannot be at the middles. Otherwise, R's will not have 3 spaces between them. So second, we should keep in mind that this will be multiplied by 2. Whatever possibilities are there, it will be multiplied by 2 because the reflection is also possible. There is one more possibility that the first thing, like we were doing earlier, first is blank, means with something else, but not these. These are 4 E's. And then we have R and 3 spaces. This is another possibility. These are only 3 possibilities which will be multiplied by 2 later. Yeah, because E cannot be at any other place other than these 6 cases. Okay, but now let's see what we can do about them. So in this case, E's have their place one fixed, and we have 1, 2, 3, 4. R's also have their places fixed. Even if they change their places, there's nothing going to happen. So only 1, 2, 3, 4. These 4 can change their places, which will be the remaining. And none of them are repeating because only R and E are repeating. So we don't have to care about this. So 4 factorial times 2 will be this case. What about this? The R, again, they are fixed. Even if they change their place, no difference will make. E will also, even if they change their place. So it will be again 2 times 4 factorial. And obviously here also 2 times 4 factorial because we are calculating the positions one by one. So it will be basically 6 times 4 factorials is the answer. 6 times 4 factorial, which is 24. Yeah, so 24 times 6 will be 144. Okay. C. Find the probability that randomly chosen arrangement of 10 letters in the word regenerate is one in which the consonant G and RRT and vowels A, E, E alternate so that no 2 consonants are next to each other and no 2 vowels are next to each other. Okay, so consonant, vowel, consonant, vowel, consonant, vowel. There are 5 E's, so this becomes our job. This makes our job easy. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, now G, N, R, R, T, they have their fixed values. Okay, so there are 5 of them, the 5 factorial, but something is being repeated. R is repeating, so 2 factorial. Again, 5 factorial will be for the vowels, but 4 of them are repeating. Okay, yeah, but it can be VC, VC, VC also. V and C can change their place, so we have to multiply it by 2 because they can interchange their places also. So this will be our total number of combinations, but they are asking probability. Yeah, so we will divide this by the total number of possibilities we had. How many? 75,600. Whatever answer we get here, we'll divide that by 75,600. So let's see how much we get. It comes out to be 600, just 600. So probability will be 600 divided by 75,600, which is 0.007936. This is the probability.